And today is 11th video of our UPSC Civil Service Mains Examination previous year question solution. And today we will see three questions of metal cutting of 2021 as well as 2020 as well as 2019. Three questions we will see. And here today I will not going to read all the data. I will just underline the given data and mark it as a notation with their usual meaning. So first of all, I'm going to clarify the notation. Alpha is equal to rack angle. Okay, R is equal to chip thickness, phi is equal to shear plane angle. Here F, it is given as that is frictional force, and this is normal to the friction. Fs, that is shear force in shear plane, and normal force, that is normal to shear, normal to shear. Okay, and this is the equation between phi and alpha and R. So these are the usual notation, and Fc, that will be cutting force and it will be in horizontal direction, and Ft will be thrust force, that will be in vertical direction. Okay, so without wasting any time, let's start. So this is the first question from 2021 paper. In orthogonal turning, that means we will use our regular formulas. Rack angle of 10 degree, that means alpha is given as 10 degree. Then chip thickness ratio, R is also given as 0.2. Horizontal cutting force, that means I will write it as a Fc. Okay, so Fc will be 1400 Newton, and vertical cutting force, that is Ft. Here you might have doubt that why thrust force is more. Yes, in general case, the problem that we have solved till now in our academics or wherever, their horizontal cutting force is more and vertical cutting force is less, but it is not always necessarily true. There may be vertical cutting force more than the horizontal cutting force. We have to determine shear plane angle, that is a phi, normal force and frictional force N and F, and friction angle beta. Okay, so to first of all we have to find shear plane angle. So we will use this formula, this relation: tan phi is equal to r cos alpha upon 1 minus r sin alpha. The value of r that we have 0.2, alpha value we have, and wait a second. Yes, and again same, put the value of r and alpha and calculate it. So you will get the value as 11.53 degree shear plane angle. So this is first. Then normal force, that is normal force equation, it is given by this: F is equal to Fc sin alpha into plus Ft cos alpha. Fc we have 1400, we have Fc value 1400, alpha value 10 degree, Ft value 2000, and alpha value 10 degree. Put all the value, you will get the main frictional force, that is 2212.72 Newton. Normal force, use this formula, that is Fc cos alpha minus Ft sin alpha. Here in this case, in metal cutting operations, you have to remember the formula, otherwise you cannot solve, or even not you can start the question. Okay, so normal force here, you will get if you put Fc cos alpha Ft sin alpha value, then you will get 1031.43 Newton. Now we know the coefficient of friction mu is equal to F by N. So put that, you will get 2.14, and this value is also equated with 10 beta. Take the tan inverse, you will get the beta value, it is 65 degree. So when friction angle is greater than 45 degree, then you can consider that vertical force is more than that. Now you might have a question that why the equation we have the 2 times phi plus beta minus alpha is equal to 90 degree, that we have not used, because we have alpha value, phi value, but that equation that we can only use when there is written that minimum energy consumption. If this condition is given, then and only we can use. Or if we do not have the value of F or N, or we do not have the value of alpha or phi, so At that time we can use this formula by taking assumption, but here we have the facility to find out the F and N. Okay, and we have the coefficient of friction, so that's why we can find by this manner. So go by this method first. If there is nothing mentioned and we don't have any other option, then you can go for this Ernest Merchant theorem. Okay, add or else wherever it is mentioned, like minimum cutting energy. So this is the answer of first question, and this question of 20 marks, very easy question if you know the formula. So it's very easy to score 20 marks. So let's move to 2020 question. Again, it is the orthogonal cutting operation. Okay, here orthogonal cutting. So cutting force and thrust force are Fc is equal to 600 Newton and thrust force is 200 Newton. It is given. Inclination angle I is equal to 0. Orthogonal rack angle alpha naught is it is equal to 0 given. Principal cutting edge angle lambda is equal to 90. That means it is a purely orthogonal turning. Chip reduction ratio R dash, which is 1 upon R. So you can find here chip thickness ratio also. So when you solve this, when you take the inverse of this, you will find a chip thickness ratio as 0.577. 0.577. Using the merchant circle diagram, determine the magnitudes and of shear force, frictional force. Okay, but using merchant circle in exam you have to draw the merchant circle, but here on the computer screen it is a very tedious task to draw of the that using the shear plane angle and all that diagram. And to save the time I'm solving by using equation. But in exam, if they want in a circle diagram, then you have to draw from circle or otherwise use equation. Same, first use that equation. Tan phi is equal to r cos alpha upon 1 minus r sin alpha. That equation, we have the value of alpha as a 0. Chip thickness ratio that we have found, r is equal to 0.577. Put all this value here, you will get the phi as 30 degree shear plane angle. Now shear force equation, from here you can get, that is fc cos phi into ft minus ft sin phi. We have fc and ft 600 200. Phi value that we have found 30 degree, put there, you will find the shear force, that is 419.62 Newton and normal to the shear. Again the same formula here, fourth formula, fc sin phi plus ft cos phi. Here you can see this last formula, put that values over there and you will get 473.2 Newton. So this is the answer, just only that this thing we have to find, and it is a 20 marks question, very easy question. Next, and this is the last question of today's video. In 2019, under the orthogonal cutting operation of the workpiece aluminum, fc and ft it is given 1500 and 1000. Okay, rack angle of the tool is 10 degree. Chip thickness ratio is 0.37 given. We have to find Fn, Fs, N and F. That means all the force, shear force, normal to shear, frictional force and normal to the friction, all that we have to find. And also determine the coefficient of friction, that is mu, which is ultimately F by N. Okay, so first of all, in any case, always find shear plane angle, that is R cos alpha divided by 1 minus R sin alpha. Alpha value we have given 10. Chip thickness ratio is also given 0.37. Put all these two value, you will get shear plane angle phi, it is 21.3 degree. Okay, now we have all these four formula, that is fc sin phi and ft, sorry, uh, wait a second. Okay, these four formulas here I'm highlighting with other colors, that is this, that we have used fc cos sin phi. And so put all the values alpha, phi, theta. So I'm going to write the direct values over here, because I'm not going to write repetitively all the things. You know the formula, because you have to know the formula at this level, because you are preparing for mains. So shear force Fs, that is 1034.3 Newton and normal to shear force, that is 1476.56 Newton, and frictional force F is equal to 1245.28 Newton, and normal force, that is equal to 1303.56 Newton. So these are all four values, and if you want to find mu, that is mu is equal to 0.95, that is ratio of F by N from these two values. Put over here, you will get mu is equal to 0.95. So this is the answer, all that they required. The only thing that is you need to remember the formula. So this is again 20 marks, very easy question. You can score this kind of question very easily. So I hope you like this solution. I may be very fast, but this is the only way to cover all this numerical. Okay, otherwise it will take too much time. I hope you like this video and try to solve by yourself also to match with the answer. So thank you for watching. Tomorrow we will meet with the new questions.